So we're here at DVD and I'm with Kieron Salter, who's the CEO of the Digital Manufacturing Centre, stood in front of an NP Aerospace Ridgeback. Now here we can see we've got a couple of door catches, one over here which is a normal one and one that you've manufactured at the DMC. Can you tell us a little bit about that and what's important about what you've been able to achieve there?
Sure, so this was part of the TAMPA Spiral 1 MOD initiative, which is about looking at how additive can be enabled in the supply chain to benefit component supply, but also future capability. And so this particular example, NP Aerospace they were part of the consortium, picked a component that we thought would be able to benefit from additive from a lead time perspective. And it's important to say that because it's also by a product of what we've done, made it lighter, but as you can see from the vehicle, there's probably not much benefit in making that particular part lighter, but it's all about lead time. And this is for manufacturing of spare parts in an efficient manner and an efficient time so that we can catch up with shortages. So that's one opportunity with additive, but there are several others. One is frontline activities, so actually being able to manufacture parts at frontline for urgent needs. But the real one that I'm interested in actually is future capability in terms of designing parts with additive into a platform like this from the ground up, so that you've actually then got additive as a part of your supply chain in the future.
And am I right in saying that when you say additive, so for most people that's 3D printing, it's what extra bits can you do? There's things that you can do through 3D printing that you can't do in any other way. Can you explain a bit about that?
I mean, 3D printing's a broad term, and I guess from a professional point of view we call it additive manufacturing. Makes it sound a bit more grown up than 3D printing. But additive manufacturing is about manufacturing parts in a multitude of different materials and different technologies, but fundamentally you're manufacturing with additive process, layer by layer, adding the material you need, rather than traditional process which is subtractive, and you're taking a large billet of material perhaps and machining most of it away, turning it into low value swarf to create your components. What that allows you to do is several things. Firstly, you can eliminate tooling. Secondly, you could make things lightweight, which you couldn't make before because of the process and the way that you can make things. But the other thing is you can reduce lead time. So there are many benefits of additive, but additive is fundamentally a completely new process to the existing traditional process. So you have to design parts to get the best out of it. You have to design parts to use additive.
Okay, and briefly, what materials could we expect in additive manufacturing? So run through the material types for me.
Yeah, again, it's quite broad. So additive manufacturing has been around about 20-30 years, maybe a bit more in sort of primitive technologies. What's changed in the last 10 years has been software and material development. And now you can print from a polymer perspective in pretty much any material, but really importantly, they are engineering grade materials. So thermoplastics that make fundamentally end-use parts rather than just prototype parts, but also metals. And I think a lot of people don't realise you can print in metals, but almost any weldable metal you can easily print in, either with laser powder bed, which is lasers and powder, melting the powder and creating solid parts, or actually with large format direct energy deposition technologies where you're actually using welding technology to make parts. So lots of different materials.
And this part here is made out of?
This is laser powder bed in titanium.
Titanium. That's the bit we needed to know. Thank you very much indeed, Kieron. That's us finishing here at DVD.